Hi students, this is the last section of Chapter 4, 4.8, Functions and Relations. You will notice in this section too, it's a little bit of review of what we've already talked about with functions, but there's a few new concepts you're going to learn here as well. So what is a function? Remember, please write down everything you see within the notes. You need to write down the examples, you need to write down the definitions, you need to write down the charts and anything else you see me right here. So a function is for every input, there's exactly one output, and that will be something you've heard before. We talked about it last semester. A relation, this is something new. This is any set of ordered pairs. So our first example here, it says decide whether the relation is a function. If so, give the domain and range. Remember, your domain is your x value and your range is your y value. So you're going to look at both of these examples for your input-output and decide if it is a function. So if we look at A here, for every input, is there exactly one output? And if you look at this, there is. So we would say, yes, this is a function. And then you could say for every input, there's exactly one output. And then you're going to label the domain and the range. So for your domain values, that's going to be 1, 2, 3, and 4. For your range values, that's your y, that's going to be 2, 4, and 5. For B here, you'll notice when you look at the value 1 is going to both 5 and 7. So there's not exactly one output for each input right here. So we're going to say, no, this is not a function. Again, because there is not exactly one output for every input. And we don't need to label the domain and range because it's not a function. Again, this should be a review from what you've seen previous semester. Now, what's going to help you determine if a relation is a function or not is what we call using the vertical line test. If you look at these 4 different examples right here, there's graphs. The graphs are the blue lines, and you'll notice for each graph there is a dashed red line going through each graph. And with what we call the vertical line test of a function, a relation is a function of the horizontal axis variable if and only if no vertical line passes through 2 or more points on the graph. So what that means is if you use the vertical line test, you put a vertical line going through the graph. If it only touches the graph at one location, this means it is a function. If you look at the second example, when you put a line, the vertical line test, it only passes that graph once, so that is also a function. But notice the last 2 graphs. If you draw the vertical line and look at the vertical line test, notice that vertical line is touching the graph at 2 places, so this would not be a function, not a function, along with the very last one, not a function. So you're going to use the vertical line test in this section to also help you determine if a relation is a function or not. Another thing that you're going to see in this section here is what we call function notation. And what function notation is, the symbol f of x is going to replace the y in what we see function notation. So if we look here at example number 2, it says evaluate the function for the given value of the variable. So we have here f of x. So f of x really is replacing y. And we have here 2x minus 3. So what they want you to determine is what your f of x, what your function notation is going to be, technically your y. So almost think of this as y equals 2x minus 3, and plugging in negative 2 in for x. So we have here, and I'll rewrite this as the function notation, 2 times x is negative 2 minus 3. 2 times negative 2 is negative 4 minus 3. So my f of x value here is going to be negative 7. And that'll be my answer. You might also see here too g of x, or sometimes you might see here h of x. Those are function notations, and that technically is just really replacing y. So if we look at b right here, we have g of x equals negative 5x, and x is equal 0. So you are going to plug in your function notation, or you're going to plug 0 into your function notation to solve for your g of x. So we could say g of x equals negative 5 times 0. Negative 5 times 0 is 0, so my g of x here is just going to be 0, and that'll be my answer. So those are some situations of examples you're going to see in this section, and that is it for this lesson.